Hello everyone, I am Soumyashree Senapati, Assistant Professor, Vedang Institute of Technology. In our previous classes, we learned about how to calculate unit weight of soil using three methods, like core cutter method, wing balance method and submerged mass density method. So, in this class, we will learn another method, that is our sand replacement method. So, first sand replacement method is a type of method that is used generally in case of field. It is field method. We just take the apparatus in field and we conduct the test there. So, to conduct sand replacement method, we need these three apparatus. First one is your cylindrical calibrating container. Okay, and another one is sand pouring cylinder. Next one is metal tray with a hole. Also, we need one spatula and that's all. So, now we will learn how to use these three things to calculate to conduct the sand replacement method. So, first we will take the metallic plate and just conduct one soil excavation. This soil excavation will do up to 15 centimeter. We will just excavate this soil up to 15 centimeter, and what we will do? Then this excavated soil we will take and put it into the metallic plate. Okay. So, now this metallic plate will be filled with soil and we will take that as W2. So, what is our W1? Okay. Next come to what is W1. So, till now we have taken the soil and weighed it and the weight becomes W2. So, to know W1, what we have here, one sand pouring here, one sand pouring cylinder. So, now we will took that sand pouring cylinder and fill it up to this length, so that these to these will be our 0.5 centimeter. We will fill the sand pouring cylinder. This is our sand pouring cylinder. Okay. So, this sand pouring cylinder we fill it up to 0.5 centimeter and the total length is 385. Here all dimensions are in mm. Okay. So, next what? This is filled with a sand. So, we will take this cylinder and put it here, put it into this excavated soil area. Okay, we have the sand pouring cylinder. So, now this is filled with, completely filled with what? Our dry soil, or you can say dry sand. Okay, so here we have one shutter. Now we can see this soil we have already taken. This soil has some moisture in it. So, now it is completely vacant. So, here we took the sand pouring cylinder and open this shutter. Okay. So that this area, this vacancy will be filled by the soil present in the sand pouring cylinder. So, this will fill like this manner. Okay. Why? Because the sand pouring cylinder have the structure like triangle here. Okay. So, we have this excavated area soil like this manner. Okay. So, here we got the soil here. Now, take it as W3. Right. So, here till now the soil From these two, we will come to this level. Okay. So now this soil we name that as W4. Okay. Here we have the soil up to W4, and this soil we will take that as W cone. Okay. So here you can see the proper diagram that now we have up to this length the sand, and it comes like this and it will be filled in this manner. Okay. So that this surface will be level surface. Okay. Now comes to the calculation. So till now, okay, here is the total procedure. We have till now W1, W2, W3, W4 and W cone. Again I can say like first we have W1 here. Total the sand pouring cylinder, we take that as W1, and here the soil we excavated here and take that and weight down the weight process. So we have that as W2. Next, here what soil comes to this place, we will name that as W3. Okay. So, and also here the soil left behind, those are W4. Okay. And so here is the complete procedure. Like I have already told that it is field method. Okay. And we just excavate a small pit and excavated the soil sample and weighed it. So a calibrated cylinder containing sand is placed over the excavated pit and is filled with sand. As I have already told you that we use the sand pouring cylinder. The volume of pit is obtained from the calibrated cylinder, like as per Archimedes principle. Okay. So here we just calculated, we take the soil. So the volume of soil will be equal with the soil, the area of this soil. Okay. So the volume we got here is equal with this. So here that is written, volume of the pit is obtained from the calibrated cylinder. So the bulk unit weight is calculated and we will calculate now the bulk unit weight. Okay. So the main and the most important part is we can conduct this process for gravel, sand and dry soil, right. So till now we have used 3 methods, but those methods we can conduct for gravelly sand, for dry sand, we can conduct those process. But sand replacement method is the one and only method that we can conduct for gravelly soil. Okay. That's why sand replace method is most important method in our calculation of unit weight of soil. So here is the whole calculation, as we already have W1, W2, W3, W4, but here in this calculation we only need W1 and W4. So to calculate volume of sand in whole, so to find out the volume, as we have already known that gamma is our unit weight. To find out gamma, we need W and V. W is our weight of soil, V is our volume of soil. Okay, so gamma is the unit weight of soil. Okay, so now what? Here we have the volume, we need to calculate the volume. So we can use the formula as W by gamma. Okay, so to find out the volume of sand, here we have weight of sand filling in hole. Here you can see we need to find out this. Okay. we need to just find out this weight of soil and the volume of soil. So, to find out the volume, we have weight of sand filling hole. So, to find out that W hole, we can find out like W1 minus what? W4 plus W cone, right? Like here. We need to just find out this. So, as W1 is what? W1 is the total sand present here. Total sand present in container. Let's take the sand pouring cylinder as container. So, from subtracting W1 and this part and this part, we can have this. How? First, here this container is filled with sand. So, we take that as W1. When we open the shutter, what happens? The soil level comes from this to this, right? So, now W4 is here. Here. W4 is your presence of soil in container after opening the shutter. Okay. So, now we have the W4 and the W cone is this part. Okay. As I have already told you that there will be some presence of soil. We take that as W cone. So, from subtracting W4 plus W cone from W1, we will have W hole. That is the presence of soil in hole. Okay. And by dividing it with gamma sand. Okay. We already have the unit weight of sand. So, now the volume of sand in hole will be equals to the volume of soil in excavated soil. From what? From Archimedes principle. The volume of sand in hole will be equals to volume of soil excavated from hole. Here we have the volume. So, we can write the formula here. And the volume of soil excavated from hole will be weight of excavated soil upon gamma. So, this gamma will be our what? Bulk unit weight. Right? So, now from this whole equation, we can have from this whole equation, we can have the value of gamma bulk. So, our gamma bulk will be, we can take this to this part, and so here we take the weight of excavated soil as W dash. W dash into gamma sand upon this part. Here. Here, in this way, we have find out the gamma bulk or bulk unit weight. Okay. So, in this way we can find out the unit weight of soil by using field process. So, if we need to conduct the process in case of field, so by using lastly by using this formula we can find out the unit weight of soil. So, now we have done with the unit weight of soil by using 4 methods, and we learn about those 4 methods. So, thank you so much.